right, so here is the back of part 2 of the review. 49 says, find the value of each variable. So we've got x's and y's in here. The y's are on the side lengths, the x is on the angle, so they don't really relate to each other. These two sides are congruent because it's an isosceles triangle. So 4y minus 2 equals 2y plus 2, which means that 2y equals 4 and y equals 2. There you go. All right, so then I need to find x. Well, I've got that this angle's labeled, this angle's labeled. I don't have anything here. I cannot put an x here because I don't know what it is because there's already an x in the problem. But since these sides are congruent, I know that these angles are congruent, so this is also 6x plus 8. So these three angles add to give me 180. So I know that 80 plus 6x plus 8 plus 6x plus 8 equals 180. So that means that gives me 12x, then 8 and 8 is 16, and 80 is 96. That's equal to 180. So 12x equals 84, and x equals 7. So on 51, you've got a couple of options here. You can set this up as a system, meaning that these two sides are congruent, therefore these angles are congruent, so I can set these equal to each other, but that gives me two variables. Then I can also add all three of these up and set them equal to 180. That gives me another equation with two variables, and that totally works. But because they gave you that this is 52, you could also go ahead and find the measure of each one of these angles here, and then just set each one of those equal to that. So let's call, this is x, this is y. Let's call just each angle measure z since they're congruent. So that means that 52 plus z equals 180. So 2z plus 52 equals 180. So 2z equals 128, which means that z equals 64 degrees. All right, so each one of these angles that are congruent to each other have to both be 64. So instead of me going down the systems route, I now know that 6y minus 2 has to equal 64, and that 4x plus 20 equals 64. And then I can just solve each one of those for x and y. Still kind of a system problem, I guess, but it's not nearly as complicated as what it might be if I had to do it differently. So this is going to give me 6y equals 66, so y equals 11. And then 4x equals 44, so x also equals 11. X and y do not always equal the same thing. Keep that in mind. All right, 52. Now, the way we did these problems, this is when we were talking about if a point is equidistant from two sides of the angle, then it's on the angle bisector, so we know those have to be congruent. But now that we have some more information under our belt, I want you to look at this differently as well. If I look at these as two triangles and not really looking at a point that is, equidistant away or whatever, but if you look at these triangles, we know that this is congruent to itself. These two sides are obviously congruent. Then you've got these right angles. So these two triangles are congruent by HL. Since the triangles are congruent, that means these angles have to be congruent. So you can look at it as this point is equidistant from two sides of the angle, so it lies on the angle bisector, or you can look at this as two congruent triangles. Of course, we can't assume that they're congruent. We have to have a way to prove it. We do have enough information to say, okay, these are congruent by HL. Since they're congruent, all their other pieces are congruent, which means those two are. So 3x plus 5 equals 4x minus 8. Let's move my x over here, add this over here. I get 13. They didn't ask me for x. They asked me for the measure of angle MNP. So I've got to plug it back in. I can plug it back into one of these. I'm going to do 3 times 13 plus 5. So that's 39 plus 5, which is 44. And then if this is 44, this is 44. So the measure of the angle is 88 degrees. So over here, same kind of thing. This is the angle bisector. So any point on the angle bisector is the same distance away from each side of the angle. We know that. But if we look at this as two different triangles, we know this is congruent to itself. We can say that these two triangles are congruent by angle, angle, side. Since the triangles are congruent, these other sides have to be congruent as well. Just a different way to look at it. So 3x plus 5 equals 6x minus 7. So that gives me 3x on this side. I add that 7 over there. It's 12. So x is 4. Nobody asked me for x. They asked me for the length of ms. So 3 times 4 plus 5. That's 12 plus 5, which is 17. And that is not degrees. All right, we're going to list the angles and sides of each triangle in order from smallest to largest. All right, so obviously, I don't really have to worry about listing these sides. We can see that. In this case, I really want to list the angles. So smallest angles across from shortest side. So my shortest side is 4, which means my smallest angle is S. My next smallest angle is T. He tried to escape, but he really belongs up there. And then that means that leaves angle R. On this one over here, in order to be able to actually answer this question, I have to find the missing angle, which is 58 degrees. So shortest sides across from smallest angle is A, so line segment BC, and then line segment AC, and then line segment AB, from smallest to largest. Okay, so then I want to see if it is possible to form a triangle with these side lengths. Once my board cooperates, it's going to jump on me in a second. Okay. So I've got to look at, this isn't asking me what kind of triangle, like if it's acute, obtuse, or right. We're not even there. It's just, does it even make a triangle? So any two sides have to add up to be greater than the third side. So 4 plus 9, that is less than 15, not greater than 15. So the answer here is no. And my work is my explanation, basically. Here, 9.1 plus 1.1, well, that's definitely going to be greater than 8.2, so that's good. Then if I do 1.1 plus 8.2, that would give me 9.3. That's greater than 9.1, so that's good. And then clearly 9.1 plus 8.2 is going to be greater than 1.1. Those all work. My answer is yes. When I go over here, 4 plus 8, that is equal to 12, so that does not work. And again, my work serves as my explanation because any two sides have to be greater, their sum has to be greater than the third side. Okay, so when I'm looking for a range of measures of the third side length we'll call x. It can range anywhere from the two sides we know added together to those two sides subtracted, but you got to take the absolute value, so you get the positive version of that. So that means this range is from 6 to 16. And then here, same thing, 3.8 plus 9.2 and 3.8 minus 9.2, but I take the absolute value. So that is going to give me 5.4 to 13. These are my ranges. Okay. All right, on the right-hand side. I didn't give you any room at all to work 63, so we're going to work it above it. But it says AB is parallel to CD if the slope of AB is negative 2/5 and the slope of CD is negative x over 15. Find the value of x. Well, if they're parallel, their slopes are equal. So negative 2 over 5 equals negative x over 15. I can just cross multiply, so that's going to give me negative 30 equals negative 5x, which means x equals 6. Okay, for what value of k will the graph of y equals kx minus 6 be perpendicular to the graph of y equals 4/7 x plus 5? All right, so I'm looking for k. These are both in y equals mx plus b. That's good because I can look at their slopes here. Since this says perpendicular, I do not want the slopes to be equal. They should be negative reciprocals. So I do not want k to equal 4/7. I want k to equal negative 7 over 4. So then I can just solve for k. There you go. I've solved for k. I'm done. All right. So next one. I want to find the value of y so that AB has a slope of negative 3. So I need to find the slope. Here, slope is delta y over delta x. That's going to be negative 2 minus y over negative 7 minus a negative 9. Gives me negative 2 minus y over 2. So that's the slope of AB. I want that to equal negative 3. So negative 2 minus y over 2 equals negative 3. So now I just got to solve for y. So I multiply both sides by 2. That'll give me negative 2 minus y equals negative 6. Add 2 to both sides. Negative y equals negative 4. So y equals 4. All right, so I want to write an equation of a horizontal line. Horizontal line. Remember, your horizontal lines, when you rotate that around, they are y equals lines. So it's just a y equals some number. Well, if it goes through this, it has to equal this y. So y equals negative 7, and there you go. All right, so then I want to write an equation in point-slope form. Make sure you know what point-slope form is. That is your y minus y1 equals m times x minus x1 version. I want it to be perpendicular to this, which means the slope, my perpendicular slope that I'm actually using is 3. Right, and it contains these 2 points right here. This is a piece of cake. This is y minus y, which is 16, equals the slope, which is 3 times x minus 6, and I'm done. All right, so then I want to write an equation in slope-intercept form. That is your y equals mx plus b form. It contains this point and is parallel to this line. This is in point-slope form, so you can easily see what the slope is here. It is 3. Since it is parallel, that is the slope that I use. Even though I want it in y equals mx plus b form, I'm going to start by putting it in this form and just work my way through it. I think that that is way easier to do. So that means I'm going to get y minus 2 equals the slope, which is 3, times x minus 4. Then y minus 2 equals 3x minus 12. So y equals 3x, not plus, but minus, once it cooperates. Because I'm going to add 2 to both sides, that makes that a minus 10. There you go. All right, so write an equation in point-slope form, perpendicular bisector of this right here, okay, or the line segment containing those 2 points. So if I want the perpendicular bisector, I need the slope and I need the midpoint. Okay, so I start off by finding this slope, delta y over delta x. It's going to give me 2 minus 2 over negative 7. That's totally a 3. Negative 7 minus 3. That gives me 0 over negative 10, which is just 0. Now, that's not the slope I actually want. I want the slope of the line perpendicular to that. So my slope is actually undefined. Right? My slope is undefined, which means that you need to think about which line it is, which one has no slope. Remember, if you're skiing, this right here you can ski on. It's just zero fun. This is undefined slope. That's when you would fall off. So that is your x equals lines with no slope. You cannot actually write it in point slope form. So this is not a great question. So we're going to write an equation of a line, but it's going to be an x equals line because our slope is undefined. But to know what that x does equal, I still have to find the midpoint. Because if you remember, if you actually graph these two little points here, this is at 3, 2 and negative 7, 2. You're looking for the perpendicular bisector of that. And so you got to know which point it goes through. It's going to go through the midpoint, but it's going to be a vertical line. So midpoint is going to be 3 plus negative 7 over 2, 2 plus 2 over 2. So that's going to be negative 4 over 2, which is negative 2, and 4 over 2, which is 2. Remember, this is undefined, so that is your x equals line, and x equals this is just a negative 2. All right, then 83. I'm going to write an equation in slope-intercept form. Slope-intercept form, that is your y equals mx plus b, for a line containing these 2 points parallel to this one. So parallel, the slopes are the same. Slope is 1/2. So again, even though I want it in this form, I'm going to start off with y minus 3 equals 1/2 times x minus 5. So y minus 3 equals 1/2 x minus 5/2. Then I'm going to have to add 3 to both sides, so y equals 1/2 x minus 5/2 plus 3. But I need my common denominator, so I'll make that into 6/2, which means I get y equals 1/2 x plus 1/2, and that is your equation. And that is the end of review part 2.